The concept of a small, suitcase-sized device capable of producing fresh water from seawater using only sunlight is no longer a science fiction fantasy but a tangible reality being developed by scientists at MIT and Shanghai.
This innovative device operates without the need for fuel, electrical wiring, or expensive components, making it a sustainable solution for regions where water scarcity is a growing crisis.
Unlike traditional desalination methods, which often rely on energy-intensive processes like reverse osmosis, this solar-powered system avoids the environmental pitfalls of toxic brine discharge and high maintenance costs.
For remote islands like Kiribati, where rising sea levels and prolonged droughts have devastated freshwater supplies, this technology could be a lifeline, offering a reliable source of clean drinking water without further harming marine ecosystems.
Kiribati, a nation composed of 33 low-lying coral atolls scattered across the Pacific Ocean, faces an existential threat as saltwater intrusion contaminates its limited freshwater lenses, which are natural underground reservoirs formed by rainfall.
Its capital, South Tarawa, experiencing population densities surpassing Tokyo, the strain on already scarce water resources has reached a critical point, leaving families dependent on rooftop rainwater collection systems that fail during prolonged dry spells.
Traditional desalination plants, such as those attempted on Banaba Island, have proven unsustainable due to their reliance on costly fuel, frequent repairs, and the generation of harmful brine waste that damages ocean life. The new solar-powered device, however, draws inspiration from the ocean's own thermohaline circulation, mimicking natural processes to desalinate water efficiently without mechanical pumps or filters.
At the heart of this invention is a hydrophobic membrane that allows only water vapor to pass through, leaving salt and impurities behind while preventing clogging through a self-cleaning mechanism driven by gravity and heat.
By tilting the device slightly, the system encourages dense, salty water to sink away from the membrane, creating miniature currents that continuously flush out excess salt without external energy input.
In testing, the device has demonstrated remarkable efficiency, producing up to 6 liters of fresh water per hour using nothing but sunlight, with no decline in performance even after 180 hours of continuous operation.
Its environmental footprint is minimal, as it avoids the toxic brine byproduct of conventional desalination and operates entirely on renewable solar energy, making it a truly sustainable solution for water-scarce regions.
Beyond Kiribati, this technology holds promise for other areas grappling with water shortages, from drought-stricken California to arid regions of sub-Saharan Africa, where access to clean water remains a daily struggle.
Its modular design allows for scalability, meaning it can be adapted to serve individual households or entire communities, providing a flexible and affordable solution to water stress.
The projected cost of producing water with this device is just 1/5 of a cent per liter, making it cheaper than tap water in many developed countries and far more accessible than bottled or trucked-in supplies. For vulnerable populations, particularly in remote or disaster-stricken areas, this innovation represents more than just a technological advancement. It offers dignity, resilience, and a path toward water security in an increasingly uncertain climate. By harnessing the natural forces of sunlight and ocean currents, this breakthrough redefines the possibilities of desalination, presenting a future where clean water is not a luxury, but a universally accessible resource.
The implications extend beyond immediate survival, challenging global communities to rethink their relationship with water and adopt solutions that work in harmony with nature rather than against it.
As climate change intensifies, bringing more frequent droughts, rising seas, and extreme weather, technologies like this solar-powered desalination device may become essential tools for adaptation and survival. For Kiribati and other island nations on the front lines of climate change, this invention is not just a scientific achievement, but a beacon of hope, proving that even in the face of overwhelming challenges, human ingenuity can provide answers.
The simplicity and scalability of this system make it a viable option for widespread deployment, offering a practical and sustainable alternative to the costly and environmentally damaging desalination methods of the past. Its passive operation means it can function in off-grid locations, providing clean water to refugee camps, rural villages, and disaster zones where infrastructure is lacking or non-existent. Unlike large-scale desalination plants, which require significant investment and energy, this device can be manufactured and distributed at a
fraction of the cost, democratizing access to clean water. The membrane technology at its core is a game-changer, eliminating the need for frequent maintenance and ensuring long-term reliability, even in harsh and remote environments.
By avoiding the use of electricity or fossil fuels, the system reduces both operational costs and carbon emissions, aligning with global efforts to combat climate change while addressing water scarcity. Its ability to produce fresh water without harming marine ecosystems sets it apart from conventional desalination, offering a model for sustainable development that prioritizes environmental stewardship. For coastal cities facing dwindling freshwater supplies, this technology could supplement existing infrastructure, reducing reliance on overburdened rivers and groundwater sources. In agricultural regions plagued by drought, it could provide a reliable water source for irrigation, helping to stabilize food production and livelihoods in the face of climate variability.
The device's potential to transform water access in some of the world's most vulnerable communities underscores the importance of investing in innovative, scalable solutions to global challenges.
Its development also highlights the power of interdisciplinary collaboration, combining insights from engineering, environmental science, and material design to create a solution greater than the sum of its parts.
As water stress becomes a reality for billions of people worldwide, the demand for affordable, sustainable, and decentralized water solutions will only grow, making technologies like this increasingly vital.
The success of this solar-powered desalination device serves as a reminder that some of the most effective solutions are those that work with nature, leveraging its inherent processes to meet human needs without causing harm.
For Kiribati, where the ocean is both a threat and a potential source of salvation, this innovation offers a way to turn the tide on water scarcity, providing a lifeline to communities on the brink. Beyond survival, it represents a step toward climate resilience, empowering communities to adapt and thrive in the face of environmental change rather than merely endure it.
The broader adoption of such technologies could redefine global water management, shifting the focus from large, centralized systems to decentralized, renewable-powered solutions that are more equitable and sustainable. In a world where water conflicts are on the rise, this device offers a tool for cooperation, enabling shared resources to be used more efficiently and sustainably across borders. Its low cost and simplicity make it accessible to the communities that need it most, bridging the gap between cutting-edge science and real-world application in ways that traditional infrastructure often fails to do.
The lessons learned from this breakthrough extend beyond desalination, inspiring new approaches to other pressing challenges, from renewable energy to waste management by mimicking nature's efficiency. For policymakers and investors, this technology presents an opportunity to support scalable, impactful solutions that address both immediate needs and long-term sustainability goals. As the device moves from prototype to widespread use, its success will depend on collaboration between scientists, governments, and local communities to ensure it meets the diverse needs of different regions. The story of this solar-powered desalination device is not just about innovation, but about hope, proof that even in the face of daunting global challenges, human creativity and perseverance can find a way forward. For the people of Kiribati and for countless others living on the front lines of climate change, this technology is more than a machine. It is a promise of survival, dignity, and a future where water is no longer a source of fear, but of life. The ocean, once a threat as rising tides encroach on homes, may now become a source of sustenance, providing fresh water where rain no longer falls and rivers no longer flow. This shift in perspective, from seeing the sea as an adversary to recognizing it as an ally, is perhaps the most profound impact of this breakthrough, offering a new paradigm for living in harmony with our planet. As the world grapples with the interconnected crises of climate change, water scarcity, and environmental degradation, solutions like this solar-powered desalination device point the way toward a more sustainable and equitable future. By harnessing the power of the sun and the wisdom of natural systems, humanity can overcome some of its greatest challenges, turning scarcity into abundance and despair into hope. The journey from idea to implementation is never easy, but the potential rewards, millions of lives saved, ecosystems preserved, and communities strengthened are immeasurable. For Kiribati and other vulnerable nations, this technology is not just a tool, but a testament to resilience, proving that even the smallest and most remote communities can lead the way in innovation. In the end, this solar-powered desalination device is more than a scientific achievement. It is a symbol of what humanity can accomplish when we work together, guided by ingenuity, compassion, and a shared commitment to a better world. The future of water security may well depend on our ability to embrace and expand such innovations, ensuring that no one is left behind in the fight against climate change and resource scarcity. For now, the sun continues to shine, the ocean continues to flow, and with this breakthrough, the promise of clean, accessible water for all moves one step closer to reality.